Hi everyone. So today we will see a problem in mesh analysis. So here it is a two-loop system. So the first loop is P, Q, S and P, and the second loop is Q, R and S and Q. So first we will take the direction of current. So let us take the direction of current as I1 and I2. So here we have to find the two currents I1 and I2. So first we will take KVL in loop 1. So here the I1 current flows to 30 ohm resistor. So here it is 30 into I1 plus. So now in 10 ohm the current I1 flows in clockwise direction and I2 it flows in anti-clockwise direction. So therefore it is 10 into I1 minus I2, which is equal to the voltage source. So here the current needs to be positive terminal. So we take it as 120 volt. So here we will find it as 40 I1 minus 10 I2 is equal to 120. And we will apply KVL in second loop, which is Q, R, S and Q. So here we have 50 ohms and the current flows I2. So 50 I2 and through this 10 ohm the current I2 flows from down to upward and I1 flows from up to downward. So here it is plus 10 I2 minus I1 and equal to the volts here. So the direction of current everything is to minus, so it is minus 60. So we will rearrange and write this equation minus 10 I1 plus 60 I2 is equal to minus 60. So we will take this as equation 1 and let this be our second equation. So we have to solve this two equation and find what is I1 and I2. So we will keep the first equation as it is 40 I1 minus 10 I2 is equal to 120. And in the second equation we multiply it by 4. So it gives minus 40 I1 plus 240 I2 is equal to minus 240 volt. We will solve this. So I1 will get cancelled. We will have 230 I2 is equal to minus 120. Therefore I2 is equal to minus 120 divided by 230. So minus 0.521 ampere. So this is the value for current I2. Next we will substitute this I2 in any of the one equation and we will find I1. Let us substitute the value of I2 in equation number 1. So from 1, so 40 I1 minus 10 into minus 0.521, which is equal to 120. So here it is 40 I1 plus 5.21 is equal to 120. So 40 I1 is equal to 120 minus 5.21. So I1 is equal to 114.79 divided by 40. So I1 is equal to 2.869 ampere. So the value for I1 and this is the value for I2. Thank you. Again the same problem. So now we will solve this problem by using inspection method. So here it is R into I is equal to B. So here it is n cross m, the size of the batteries for R, and n cross 1 is the size of batteries for I, and n cross 1 is the size of batteries for B. So we have to find what is the size of the battery. So here n will be equal to number of loop. So here we have a 2 loop system. So n is equal to 2. So the size of the matrix what we get is R which is equal to 2 into 2 and I which is 2 into 1 and B which is 2 into 1. So we'll find one by one. So first for R matrix. So the first element will be R11, R12, R21, R22. So we will first find what is R11. So from the loop 1, what are the resistors which are connected to it, we are going to add it. So here we have 30 ohms and 10 ohms. So it is 30 plus 10 is equal to 40 ohms. Next R12 will be equal to R21. This is equal to the common resistor for both the loops. So here this 10 ohm, the common resistance for both the loop, and the current direction is it is flowing in clockwise direction, and here again in clockwise direction, but in opposite direction. So here it is minus 10. Next R22. So here the R22 is the sum of the resistors which are available in the loop 2. So 50 plus 10. 50 plus 10, therefore 60 ohm. So the value for R matrix which is 40 minus 10 and 60. The next I. So for I matrix the value is I1 and I2. So this is for I matrix. And next for B matrix we have to find what is V1 and V2. So in loop 1 available voltage source is 120 and the leading side is positive. So V1 is 120 and no other voltage source is given here. And in loop 2 the voltage source is 60 and the current in direction is minus. So we will take it as minus 60. So this is our V matrix. So now we will write it in the inspection method. So here it is 40 minus 10, 60 into I1, I2 which is equal to 120 minus 60. So by using Cramer rule we can solve this. By Cramer's rule, first we will find what is del. Then simply we can solve the determinant for the R matrix. So determinant of 40 minus 10, 60. So here it is 40 into 60 minus 10 into minus 10. So here it is 2400 minus 100. So here it is 2300. This is the value for del. So next we will find what is del 1. So we replace the value for the voltage in column 1. So here it is 120, 60, and the second column we can write as it is minus 10, 60. So we have to find the determinant for del 1. So it is 120 into 60 minus 10 into 60. So here it is 7200 plus 600. So it is 7800. This is the value for del 1. The next del 2, you can replace the voltage matrix in second column. So 40 minus 10, 120 minus 60. Sorry, determinant. So here it is equal to 40 into minus 60 minus 10 into 120. So it is minus 2400 plus 1200. So it is minus 1200. This is the value for del 1 and this is the value for del 2. So now we will find the loop currents I1 and I2. I1 is equal to del 1 divided by del. So value for del 1 is 7800 divided by del is 2300. 7800 divided by 2300. So here it's a correction. It is minus 60. So it is minus. So we will get here it is minus. It is 6600. So here del 1 which is equal to 6600 divided by 2300. So 6600 divided by 2300. So here the current is 2.86 ampere. And I2 which is equal to del 2 divided by del. So here it is minus 1200 divided by 2300. So here it is minus 0.5217 ampere. So here by using inspection method, also by solving the equation, we will get the same answer. Hello. So here in this problem, so using a mesh analysis, we need to determine the three mesh currents in the circuit. So here in this circuit, we have given three loops and the direction of current is already given. So I1, I2, I3. So here this is our first loop, and this is our second loop, and this is our third loop. So directly we can use the inspection method and we will find the matrix equation. So the matrix equation here it is R into I is equal to B. So here we have three loops. So the value of n which is equal to number of loops, that is 3. So the size of first matrix R is 3 cross 3 and I is 3 cross 1 and B is 3 cross 1. So first we will determine the value for the first matrix. This is R. So here first R11. So what are the elements which is connected here in the loop 1? So here it is 1 and 2. So R11 which is the sum of the two resistance value 1 and 2. So here it is 3. Next R12. So the common resistance between loop 1 and loop 2 is 1. So here it is 1. And the direction of current, so here I1 is flowing from upward to down and I2 is from down to up. So they both are in anti-clockwise. So minus. And next R13. So the common loop, common branch between 1 and 3 is 2 ohm. The direction of current here is downward direction, here it is upward direction. So here it is minus 2. Next step, R1 will be equal to R12, so minus 1. And next R22, the sum of all the resistors in second loop. So 1, 2 and 3. So total 6 ohm. And next step, R2, 3. So this is our second loop and this is our third loop. So the common resistance between 2 is 3 ohm. So here it is 3 and the direction of current here is from left to right and here it is from right to left. So it is minus. And R 2, 3 will be equal to R32. So next this value R31 will be equal to R13, so minus 2. So R32 will be equal to R23, so it is minus 3. The next last one R33, the sum of all the rest is in root 3. So 3 plus 1 plus 2. So total 6. So this is the value for R. The next for I matrix. So here we have given 3 currents, I1, I2 and I3. The next voltage matrix. So here we have to find the voltage in each loop. So in first loop we have a 7 volt source, and the sign here in the leading direction is positive, and the current again flows through the other source which is given 6 volt, and the sign which is leading here is minus. So here we will get the value for V1, which is equal to 7 minus 6, which is equal to 1 volt. And next for V2, in loop 2 there is no voltage source is given, so the voltage here it is 0. And next for loop 3, so here we have only one voltage source, the current leading direction is positive, so here it is V3, which is equal to 6 volt. So we have taken the value for voltage matrix, so V is equal to 1, 0, 6. So this is the V matrix. So now we are using Cramer method, we can find the values for I1, I2 and I3. So now we will find the value for del by using the Cramer method. The value for del is the determinant of R matrix: 3, minus 1, minus 2, minus 1, 6, minus 3, minus 2, minus 3 and 6. So when we solve this, we get the value for del, which is equal to 39. Next, del 1, replace the voltage matrix in column 1. So 1, 0, 6. Next, minus 1, minus 2, 6, minus 3, minus 3 and 6. So the value for del 1, we can solve this using a calculator. So the value it is 117 we got. Next, del 2, replace the voltage matrix in second column. So 3, minus 1, minus 2, 1, 0, 6, and minus 2, minus 3 and 6. So the value for del 2, what we got is 78. The next del 3, replace the voltage in the matrix in the third column. So 3, minus 1, 1, minus 1, 6, 0, minus 2, minus 3, 6. So the value for del 3, what we have obtained is 117. Therefore, we can find the 3 currents I1, I2 and I3. So first, I1 is equal to del 1 divided by del. So it is 117 divided by del 39. So here it is 3 ampere. Next I2, which is del 2 divided by del. So the value for del 2 is 78. 78 divided by 39, which is 2 ampere. And next I3, del 3 divided by del. So 117 divided by 39, which is equal to 3 ampere. So using inspection method, we have found the value for three currents in the loops. 3 ampere for I1, I2 equal to 2 ampere, and I3 equal to 3 ampere. Thank you. Hello. So in this problem, so in the given circuit, we have to obtain the load current and the power delivered to the load. So here in this figure, we have given the direction of current for I1, I2, I3, and here we have 3 loops. So this is our loop 1, source, 4 ohm resistor, and 1 ohm resistor, and adding to the source. And this is our second loop, so 12 ohm resistor, 6 ohm, and 9 ohm, and adding 12. So 9 ohm, 3 ohm, and 3 ohm. So this is our third loop. So here we can solve this by using the mesh analysis, and we can take inspection method. So the size of the matrix here, n will be equal to the number of loops. So here we have 3 loops, so the size of the matrix is equal to 3. So R n into n, I n into 1, and V n into 1. We have no value for n, which is 3. So R into 3 cross 3, and I into 3 cross 1, which is equal to V into 3 cross 1. So we find the R matrix first. So here the elements for the R matrix. So first R11. So the sum of all the resistors which is available in the loop 1, which is 4 plus 12. So it is 16. And next R1 and 2. So for first and second loop the common resistor is 12. So here it is 1. And we see the direction of current. Here I1 flows from top to down, and I2 is going from down to upward direction. So here it is minus. And next R13. So this is our loop 1 and this is our loop 3. There is no interconnecting resistance between 2. So the common resistor is not available. So the value is 0. And next R21. 2 and 1. We have already found the value for R12. So that will be directly equal to R21. And next R22. The sum of all the resistors available in loop 2. So 12 ohm, 6 and 9. 18 plus 9. So 27. The next R23. So here we have 9 ohm. The direction of current is in downward direction for I2, and for I3 it is in upward direction. So here the common resistor is 9. So minus 9. Next we have to find R31. So already we have found R13, that is directly equal to R31. And next R32. So we know the value for R23. So this is 9, minus 9. Next R33. So sum of all the resistors available in loop 3. So 9 plus 3 plus 15. So total 8 plus 9, 27. So this is our R matrix. So we can directly find the matrix equation, which is equal to R into I. We have 3 currents, I1, I2, I3, which is equal to V matrix. So here we can find the V matrix for this mesh. In loop 1, the voltage source available here it is 120 and no other source are available. So the direction of current leading is positive. So we can take 120 for loop 1. And for loop 2, there is no sources given. And for loop 3 also no sources is given. So the voltage is 0 and 0. So this is the matrix equation for the problem. So now we will solve and find the load current and power delivered in the load. So also we will find the mesh all the currents here. So first using Cramer method. we'll find the value for del, which is equal to determinant of the R matrix. So here R matrix is 16 minus 12 0 minus 12 27 minus 9 0 minus 9 27. So here we have to take the determinant. So after solving, we have got the value for the determinant, which is 6480. So this is the determinant value we have obtained for del. And next del 1, replace the voltage values in the column 1. So here determinant of 120 minus 12 0 27 minus 9 minus 9 27. So you have to find the determinant for del 1. So the determinant for del 1 is 77760. So this is for del 1. Next del 2. Substitute the voltage in the values in the second column. So 16 120 0 and minus 12 0 minus 9 0 0 27. So you can find the determinant for del 2. So the determinant value one we got is 3,880. So this is the value for del 2. Next we find the value for del 3. So substituting the potential values in column 3. 16 minus 12 120 minus 12 27 0 0 minus 9 0. We will find the determinant for this value, and we have obtained the determinant values 12960. So these are the del values for the given problem. So in this we have to find what is the value for I1, I2, I3. So we know the formula for I1, which is equal to del 1 divided by del. So the value for del 1 is 77760 divided by 6480. So the value for I1, which is equal to 12 ampere. Next I2, which is del 2 divided by del. So here del 2 is 3,880 divided by 6480. So here it is 6 ampere. Next I3, del 3 divided by del, which is equal to 12960 divided by 6480, which is equal to 2 ampere. So the mesh currents here are I1, I2, I3, where I1 equal to 12 ampere, I2 equal to 6 ampere, and I3 equal to 2 ampere. Also here we are asked to find the load current and the power delivered to the load. So here this is the load. The current flowing through this load is I3. So therefore the load current value, load current to 15 ohm resistor is I3, which is equal to 2 ampere. And we have to find the power delivered in the load. So power, which is equivalent to I square into R. So here we can take the current as I3 and the value of resistor is 15. So I3 square into R, which is 2 square into 15. So 4 into 15 is equal to 60 watt. So therefore the power delivered in the load here it is 15 watt. So using mesh analysis, we have found the value for mesh current and also the power delivered in the load.